So we're going to start looking at compounds, atoms, and ions. And the first comparison we're going to look at is a compound versus an atom. Now, we've already looked at atoms, and recall an atom is the simplest particle of an element. So the periodic table of elements, if we want just one of those elements, that simplest form is an atom. If we look at our periodic table, we have about 110 different kinds of atoms. There's about 110 different kinds of elements on the periodic table, and about 90 of those occur naturally in nature. And that's basically the first 90 or so on the periodic table, where they occur naturally in nature, either in the earth or in the atmosphere. A compound, though, the simplest particle of a compound isn't an atom, but it is a molecule. We combine some elements together in a fixed ratio, and these combined elements in a fixed ratio create a molecule. The important thing about a compound is that when we create a compound in this fixed ratio, we get a new substance that has new properties. Brand new substance with new properties. An example of this would be water, formed from hydrogen and oxygen. Hydrogen and oxygen, when they combine together, form a new substance, new properties. And when we're talking about compounds, there are many millions of compounds that exist or can be created from the elements. So we're not limited to 90 or 110. There are millions and millions of different compound possibilities. Well, how do we get these compounds? How do atoms form compounds? Well, first of all, it's based on the electron arrangement. And the electrons, and especially the electrons in the outer shell, determine the arrangement. Because a compound wants to have outer shells that are filled. And those outer shells are what we call the valence shells. And those outer shells want to be filled with the same number of valence electrons as the nearest noble gas. Because those noble gases, such as helium or neon or argon as shown there, their outer shells are filled with electrons, 2, 8, or 8. And it's that full valence shell that forms a compound. Some patterns exist between certain types of elements. And one of those patterns that exist are halogens. Halogens are the second to last column on the right-hand side of the periodic table, column number 17, and halogens have a tendency to gain an electron. They want one more electron. If we look at the other side of the periodic table, the first column, the alkali metals have a tendency to lose electrons. And this gaining and losing of electrons is how compounds are formed, and we're going to spend quite a bit of time looking at this gaining and losing electrons and talk about that valence shell. Well, let's compare then an atom to an ion. And again, we've already defined an atom. Atom in terms of charge is neutral. Atom has the same number of protons and neutrons, which means it has no charges. The positives and negatives equal each other. But an ion is different. An ion is a particle that's not neutral, but a particle that is charged, a charged particle. And this charged particle comes from a different number of protons and electrons. The positives and negatives aren't the same. Now, the important thing to remember from an ion is that the proton number doesn't change. It is a gain or loss of one or more electrons. That's how an ion gets its charge. It's either going to gain an electron or lose an electron and become more positive or more negative. Now there's an important thing to note. Any element on the periodic table can be either an atom or an ion. That is very, very important. So we're going to be looking at elements from the periodic table, and sometimes they're going to be an atom that are neutral, no charge, and sometimes they're going to be an ion with a charged particle. So let's look at this as we compare an atom to an ion. And we're going to look at the fluorine atom versus the fluorine ion. Now, the fluorine atom, if we were to draw the Bohr diagram, would look like this. There's your fluorine atom. And notice on the fluorine atom that the center, the nucleus, has F, 9 protons in there, and around the outside we have a total of 9 electrons. 9 protons, 9 electrons. The charge is 0, and the symbol for fluorine is F. Now notice that this atom could gain one more electron. If it gained one more electron, it would have a full outer shell. That's the difference between an atom and an ion. If we were looking at the fluorine ion, we would start with the Bohr model as we did before. And just like before, we have 9 and F in the center there. Notice the electrons, that extra electron is drawn in. Now the fluorine ion has square brackets and a charge of -1. And that -1 is a result of having 9 protons but 10 electrons. And if you count all the electrons on the ion, you would see there are 10 electrons, which means there is one more negative charge in the ion. Now the important thing to also note down here is look at the symbol. The symbol for the fluorine ion is F with a minus. That -1 from here goes to the -1 down there. F minus or F1 minus. Now the same can be true about any atom. Here is the sodium atom. Sodium has 1 extra electron in that outer shell. It has a tendency to lose that electron. Right now it has 11 protons and 11 electrons, a charge of 0. If we were comparing that to the sodium ion, that extra electron in the outer shell gets booted out. The square brackets come in. It has more protons, 11 protons now, and 1 less electron, so the charge is -1. Now you have space in your own notes. What I want you to try and do is pause the video and draw the magnesium ion. So now that you've done that, let's look at the properties of ions, because just like atoms, ions have certain properties. And the first one we're going to look at is the symbol for ions. Now the good part about an ion is that an ion uses symbols we already know. The element symbols from the periodic table are the symbols that are used, and it's slightly changed by adding a charge to that symbol. Now the important thing there about the charge is that we add both a sign and a number. A sign and a number, so a positive and a negative and some number, such as these. F1 minus, or just F minus, is the fluorine ion. Here is the sodium ion, symbol and a charge. Aluminum ion, symbol and a charge. Symbol and a charge for sulfur. So that's the first important piece, the ion properties, element symbols with a charge. The other important piece is the name. We now take the nonmetal elements from the periodic table, and we change the names a little bit. The ion would end in IDE. That's how we get things like fluoride, or sulfide, or chloride. IDE. And we're going to look at that naming convention again in some more details. The other thing that's important about ions is the transferring of electrons. Now, an atom becomes stable as it fills its shells, as it gets closer to full shells, that 288. Now, the important piece here is that an atom can't do this on its own. It can't just throw an electron away, but it can transfer it to another atom. And this transferring of electrons results in our both positive and negative ions. Losing or gaining electrons will give us both positive or negative ions. And the important thing to note here is that the nucleus never changes. It's only the electrons. Protons and neutrons do not change. Only the electrons that change, gaining or losing electrons. Well, we can actually predict an ion charge from its location on the periodic table. And there's some patterns. And have a look at your own periodic table and you'll see just this. The metals, everything to the left of the staircase, forms a positive ion. Things such as the alkali metals, the first group, are all positive 1. The alkaline earth, the second metal, they're all positive 2. And then as you work your way through, you'll see the transition metals. We will see all these other metals that have multiple positive charges. Look on the other side of your periodic table. The nonmetals. All of the nonmetals form negative ions. And there's a pattern with those as well. The halogens, group 17, all have a 1- charge. They all are a negative 1, and there's one exception to all of this charges. And the exception is hydrogen. Hydrogen has only 1 electron, which means it can either be positive or negative. It's either going to give up an electron or gain an electron. So important to note, different patterns exist from the periodic table depending on the location of the element on that periodic table.